We have covered aircraft structural components in the previous lesson, and we will extend this session to learn and understand about how corrosion can affect the aircraft surfaces. There are many structural components which can be exposed to the corrosion, such as wings, fuselage, and other aircraft structures. There are mainly three types of corrosion that we are going to look out are surface corrosion, intergranular corrosion, and stress corrosion. The surface corrosion on ferrous metals other than stainless steels can be recognized as a reddish brown powder commonly known as rust. The surface of aluminium or magnesium can become covered in white to grey powdered deposits. On magnesium, there may be also deep pitting of the surface. The surface of copper and its alloys may become covered in blue-green deposits. The surface corrosion is the least damaging. It is relatively easy to spot, so it can be identified and dealt with the early stage. The microstructures of metals or alloys are made up of crystals or grains, which are separated by grain boundaries. The intergranular or into a crystalline corrosion is a localized attack along the grain boundaries or immediately adjacent to the grain boundaries. White, the bulk of grains remain largely unaffected as it penetrates the core of the metal along the grain boundaries. The rate of attack is not limited by the lack of oxygen and it is accelerated if applied to the residual stresses. As the residual stresses are present, the repeated fluctuating stress caused a separation of grain boundaries, accelerating the spread of corrosion. As a result, higher stress concentration can occur into the remaining sound material, thus producing cracks which can be speed leading to the component breaking or failure. This is the main reason how the corroded materials can break or crack. This is very dangerous task. And this dangerous task can be form of corrosion as detection is very difficult and serious. Weakening can occur before any external evidence is visible, thus the only surface indentation may be a series of hairline cracks, probably only visible through the magnifying glasses. There are no effective method to determine or limit the loss of strength which will be occurring with a type of corrosion. So, it is detected and the affected part must be immediately rejected. A combination of steady tensile load and corrosive environmental conditions produce a form of metal fatigue known as stress corrosion cracking. The stresses may be built in during the manufacture, which is introduced during the assembly, or may be applied to during the operation. The metal under stress corrodes more rapidly than the unstressed metal. It usually begins with pitting at the surface, and this increases the stress at a pit, causing a crack which can extend under the combined action of the corrosion and load until the failure occurs. The aircraft's landing gear is usually designed to withstand landing of particular maximum all-time weight and maximum vertical descent velocity of 10 feet per second or 3.15 meter per second. If either of these parameters is exceeding during the landing, then the aircraft may be damaged. The damage may also can be caused to some aircrafts by landing with a drift applied or by touchdown with a noisier tail wheel first. Some of the aircrafts are fitted with hard landing indicators which give a visual indication that specifies G forces have been executed. But in all the cases, if the crew suspects that the hard landing has been made, then all details included in the aircraft weight, fuel distributions, landing speed rate of descent, and any noise indicative of structural failure must be reported so that an inspection can be carried out prior to the next takeoff. The damage which may be expected following a hard landing will be concentrated around the landing gear, its supporting structures in the wing and fuselage around the wing, and the tailplane attachments and engine mounts. Thank you for watching the video. In the coming next session, we will learn how these structural corrosion can be minimized with the help of the aircraft manual and other safety measures.